To accurately bid an electrical job, especially for a 1600 square foot pole building garage, it's crucial to follow a systematic approach. First, consider materials and labor estimation. On the materials side, you'll need to account for electrical panels and breakers, Romex cables, outlets, switches, light fixtures, security lighting, ground fault circuit interrupters, commonly called GFCIs, and conduits and fittings if required. Then estimate the labor involved, including installing the electrical panels and breakers, running the Romex cables, installing outlets, switches, and light fixtures, connecting wires and fixtures, and testing and inspecting the electrical system. The bidding process involves several key steps. 1. Conduct a site visit to gather specific information about the garage, its dimensions, and any existing electrical infrastructure. 2. Create a detailed list of all materials required, including quantities and specifications. 3. Estimate the number of labor hours required to complete the installation based on the scope of work. 4. Determine the unit rates for materials and labor, considering factors such as market prices, experience of electricians, and local labor costs. 5. Calculate the total bid by multiplying the unit rates by the quantities and labor hours to get the total cost of the project. For example, consider a bid breakdown like this. For materials, an electrical panel rated for 200 amps might cost $200. Breakers, assuming you need 4 20 amp breakers and 2 15 amp breakers, could cost $100. Romex cables, estimated around 1600 feet, might be $400. 18 outlets could amount to $180. 6 switches might cost $60. 14 light fixtures could cost $280. 3 security lights might be $150. And 2 GFCIs could cost $40. Now for the labor estimate. Installing the electrical panel and breakers, estimating 8 hours, could be $400. Running the Romex cables, estimating 12 hours, might be $600. Installing outlets, switches, and light fixtures, estimating 16 hours, might be $800. Connecting wires and fixtures, estimating 8 hours, could be $400. And testing and inspecting, estimating 4 hours, might be $200. Breaking this down into unit rates, materials could total $1,410 and labor could total $2,400. The total bid, in this example, would be $3,810. Some helpful bidding tips include obtaining quotes from multiple contractors to compare prices. Include a contingency fund in your bid to cover unexpected costs. Consider additional features such as surge protectors or smart home integration, which may add to the cost. Breaking down the bid into specific line items provides transparency and clarity for the client. Looking at the specific electrical requirements for this garage, it includes a 200 amp underground service, 4 20 amp circuits for outlets and garage door openers, 2 15 amp circuits for 12 fluorescent lights, 18 outlets for receptacles, 2 outside receptacles, 2 security lights, 1 entry light, and 2 GFCIs, all using Romex wiring. To prepare a detailed bid, let's break down each component. The 200 amp underground service requires careful planning and adherence to local electrical codes. Ensure that the wire gauge is appropriate for the 200 amp service, referencing NEC Table 310.15b16 or similar tables for proper sizing based on conductor type and insulation. The underground installation necessitates the use of appropriate conduit such as rigid metal conduit or PVC conduit suitable for direct burial. Proper trenching and backfilling techniques must be employed to protect the conduit and conductors from physical damage. The 420 amp circuits for outlets and garage door openers must be wired with 12 American wire gauge or AWG Romex cable. Each circuit can support a maximum of 16 amps of continuous load to adhere to the 80% rule. The garage door openers should be on separate circuits from the general purpose outlets to prevent overloading. The 2 15 amp circuits for the 12 fluorescent lights require 14 AWG Romex cable. Ensure that the total load of the fluorescent lights does not exceed 80% of the circuit's capacity, which is 12 amps. Consider using energy-efficient LED alternatives to reduce the load on the circuits. The 18 outlets for receptacles should be spaced according to code requirements, typically no more than 12 feet apart. Use standard 120 volts, 20 amp rated receptacles. The two outside receptacles must be ground fault circuit interrupter protected to prevent electrical shock in wet or damp locations. Weatherproof covers should be used to protect the receptacles from the elements. The two security lights and one entry light should be energy-efficient LED fixtures. Consider using motion sensors for the security lights to conserve energy and enhance security. The entry light should be controlled by a switch inside the garage for convenience. The two GFCI should be installed in locations where moisture is present, such as near sinks or outdoor receptacles. They provide protection against electrical shock by monitoring the current flow and tripping the circuit if an imbalance is detected. All Romex wiring must be installed according to code requirements, including proper support and protection from physical damage. Use cable staples or straps to secure the Romex cable to studs and joists every 4.5 feet horizontally and every 12 inches vertically. Ensure that the Romex cable is not exposed to direct sunlight or physical abuse. When creating your bid, be sure to include costs for all necessary permits and inspections. Contact the local building department to determine the permit requirements and associated fees. Schedule inspections at various stages of the project to ensure compliance with electrical codes. In summary, the 200 amp service requires careful planning and code compliance, use appropriately sized conductors, and proper grounding techniques. The outlet circuit should be wired with 12 AWG Romex and protected by 20 amp breakers. The lighting circuit should be wired with 14 AWG Romex and protected by 15 amp breakers. The receptacles, both indoor and outdoor, should be installed according to code requirements, including GFCI protection for outdoor receptacles. The lighting fixtures should be energy-efficient LED with appropriate controls. All wiring should be installed according to code, with proper support and protection. Permits and inspections are essential for ensuring compliance and safety. By following these guidelines and providing a detailed bid, you can increase your chances of winning the project and ensuring a successful electrical installation for the 1,600 square foot pole building garage. Remember to factor in potential challenges such as working in confined spaces, dealing with uneven terrain, and coordinating with other trades. These factors can impact the labor hours required and should be accounted for in your bid. Also, consider the cost of fuel and transportation to and from the job site. These costs can add up, especially if the job site is located far from your base of operations. Ensure that your bid includes a reasonable profit margin to cover your overhead expenses and ensure the financial viability of your business. A typical profit margin for electrical work is between 10% and 20%. Finally, be prepared to answer any questions the client may have about your bid. Be transparent and upfront about your pricing and explain the value of your services. Providing excellent customer service can help you stand out from the competition and win the project. When specifying Romex or non-metallic sheath cable, ensure it is appropriate for the intended use. For example, an MB cable is commonly used for interior wiring in dry locations. If the garage has any damp or wet locations, such as a wash area, consider using UF cable, which is designed for direct burial and wet environments. The choice of conduit material for the underground service depends on local codes, soil conditions, and personal preference. Rigid metal conduit, or RMC, provides excellent physical protection but is more expensive and difficult to install than PVC conduit. PVC conduit is lightweight, corrosion resistant, and easy to install but may require additional protection in areas subject to physical damage. When selecting breakers for the electrical panel, ensure they are properly rated for the circuit amperage and voltage. Circuit breakers protect the wiring and equipment from overloads and short circuits. Consider using arc fault circuit interrupters, RFIs, for circuits that serve bedrooms or living areas to provide additional protection against electrical fires. For the fluorescent lights, consider using electronic ballasts, which are more energy efficient and provide better light quality than traditional magnetic ballasts. Electronic ballast also eliminate the annoying hum often associated with fluorescent lighting. When installing the receptacles, ensure they are securely mounted to the wall or surface and properly grounded. Use tamper-resistant receptacles, or TRRs, in areas accessible to children to prevent them from inserting objects into the slots. For the outdoor receptacles, use weatherproof covers that protect the receptacles even when cords are plugged in. These covers provide superior protection against moisture and debris. When selecting the security lights, consider using LED fixtures with adjustable heads and motion sensors. LED security lights are energy efficient, long-lasting, and provide bright, reliable illumination. The motion sensors can be adjusted to detect movement at different distances and angles. The entry light should be controlled by a three-way switch if there are multiple entry points to the garage. A three-way switch allows you to control the light from two different locations. When installing the GFCIs, ensure they are easily accessible for testing and resetting. Test the GFCIs monthly to ensure they are functioning properly. If a GFCI trips frequently, investigate the cause and correct any electrical problems. Proper grounding is essential for electrical safety. Ensure that the electrical panel is properly grounded to a grounding electrode system, such as a ground rod or water pipe. Grounding provides a low impedance path for fault current flow, which helps to trip the circuit breaker and prevent electrical shock. When running Romex cable through walls and ceilings, use grommets or bushings to protect the cable from sharp edges. Sharp edges can damage the cable insulation and create a shock hazard. When connecting wires to outlets, switches, and fixtures, use wire connectors that are properly sized for the wire gauge and number of conductors. Wire connectors provide a secure and reliable connection that prevents loose wires and electrical arcing. Label all circuits in the electrical panel with clear and accurate descriptions. Labeling helps to identify the circuits and makes it easier to troubleshoot electrical problems. Provide the client with a copy of the electrical panel schedule for their records. Before starting any electrical work, disconnect the power to the circuit of the electrical panel. Use a voltage tester to verify that the circuit is energized before touching any wires. Always follow safe work practices and wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take precautions to protect yourself and others. In summary, bidding an electrical job requires careful planning, accurate estimation, and attention to detail. By following these guidelines and providing a detailed bid, you can increase your chances of winning the project and ensuring a successful electrical installation.